So how do you, given a formula, know how to draw Lewis dot structures? Well, number one thing is you kind of have to write on your paper where you think the elements go, given just a general idea. So you have something to build from. And the rule of thumb is that for a simple molecule, when given a formula, you're going to put the least electronegative one in the center, and that would be the one that's furthest to the left. That's because those are the ones most willing to share because they're not holding on to their electrons, or they're not drawing all the electrons towards themselves. They kind of have this like push-pull situation where they're more willing to like share electrons with other things. Only exception to this rule is never put hydrogen in the center. Hydrogen can't share very well, so we don't put it there. So number one, when you're drawing a Lewis dot structure, is to put the least electronegative one in the center. So if I was trying to figure out how to draw the Lewis dot structure for this compound, I would look at that and I would say, okay, I'm going to figure out kind of how this is arranged in three-dimensional space. Between carbon and chlorine, which one am I going to put in the middle? Well, carbon's furthest to the left of my table, so it's going to go in the middle. From there, you take all the other elements given to in the formula and you put them around that center in quadrants. So we're not trying to build lines. This is a big no. That's not how things draw themselves in real life. Things flower from the center. So always imagine that you're making flowers. So we put something in the center and we flower everything out from there, kind of like in a spiral. So carbon then would go in the center and all the chlorines would flower out from the center in the different quadrants. The next step to figure out how to arrange this Lewis dot structure is to do some math. And that math will allow you to know how many bonds and how many lone pairs this structure takes on. So how do I figure out how this thing is going to bond together? I do some math. Okay, so step one, I count up the total number of electrons, once these are all bonded together, that the atom would want. And the way it works is everything wants 8 except for hydrogen, which wants 2. So if I look at this, I have 4 chlorines and 1 carbon, so 5 total atoms. And all 5 want a total of 8 electrons. So 5 times 8 then would be 40. So that's how many I want. The next step is to count up how many electrons these atoms are actually bringing to my party. So essentially I'm counting up the number of valence electrons that each one has. Chlorines each have 7. So I have 7 times 4 for 28. And then carbon brings 4 to the party, so that gets me a total of 32. Once I have my count, my next step is subtraction. So when I take what I want minus what I have a difference between 8 electrons. So I'm going to need to share 8 electrons in order to satisfy these atoms. 8 then divided by 2 will be my total number of bonds that I need to have, which would be 4 bonds then. And then to figure out how many lone pairs I will end up with, if I come to party with 32 and I'm going to use 8 of them, subtracting those 2 then tells me how many lone pairs I'm going to have. So 32 minus 8 is 24. Divided by 2, I will have 12 lone pairs. I take that information back to my structure and I make it work. So 4 bonds. Number 1, everything has to be bonded to the center. So those are my 4 bonds. Now I have 12 lone pairs, or 24 total electrons left. I simply start on the outside and start putting them out in order to satisfy my octets. So I'm going to need 3 sets of lone pairs on that chlorine to make it so he has 8. So this bond gets counted for both atoms. So now this chlorine has 2, 4, 6, 8. If I put 3 sets out here, this chlorine has 2, 4, 6, 8. If I put 3 sets out here, this has 2, 4, 6, 8. If I put 3 sets out here, that has 2, 4, 6, 8. So I've put out now 12 sets, because 3 times 4 is 12. And my middle carbon is also fine, because each of these bonds, because the electrons get shared in both directions, get counted for carbon. So carbon has 2, 4, 6, 8, because each line equals 2 dots. So that's how I figure out the dot structure for this guy. It's a pretty easy one. I probably wouldn't need all this math to figure it out, but the math helps. So let's do a slightly more challenging one, which is carbon dioxide. So for carbon dioxide, again, I put the most electronegative one in the middle, the carbon, and then I would arrange the oxygens on the outside. Now, a hint would be, in general, life arranges itself symmetrically from the center. So I'd put my oxygens out like this. If you did it slightly different than that, it wouldn't be wrong, but that's what I tend to lean towards. Okay. Now let's do our math. So how many do I want? Well, I have 3 atoms, and they all want 8 because I don't have hydrogen here. So 8 times 3 means I'm going to want 24. How many do I have? Well, each oxygen brought 6, and my carbon brought 4. So I just add those up. So I have a total of 16. If I subtract those two, I'll find out how many I have to share. So 24 minus 16 means I have to share 8, which means I'm going to end up needing 4 bonds again. 8 of my 16 are used in bonds. So 16 minus 8 means I have 8 left over for lone pairs, which means I'm going to end up needing 4 lone pairs. Now, this structure is different than the last one because if I look now, I need to put 4 bonds out. And right away I can say, well, I know I need to bond my 2 to the center because everything has to be bonded. But now I have 2 more bonds because I've only used 2 of the 4. Where can I put those 2? Well, again, life tends to be symmetrical, so I'd put out 1 on each side. So I've accounted for my 4 bonds now. Now I have 4 lone pairs. And again, I put those out, starting kind of from the outsides, however I need to get my things to octets, to get them to 8 electrons. These 2 lines means there's 4 electrons being shared, which means each oxygen needs 4 more to get to 8. So now I've used my 4 lone pairs and I'm done. That's the structure. And that's all from the idea that life flowers from the center. It tends to be symmetrical, and this math told me how many things I would need in order to satisfy myself. The goal with Lewis dot is to create a structure that represents what would happen in real life. And the main problem with Lewis dot is you could do a lot of things that life doesn't do. So you kind of have to practice and find this fine line balance between like